Hi there. So, thank you for being patient with me while I'm at the doctor's, and sorry, first period, you were stuck with me today. So, our learning target for the day is I can create residual plots and analyze the shape. Now, before you can create a residual plot, you have to make a regular scatter plot using a table of data, and you have to find the line of best fit. So that is something we already know how to do, but I'm going to teach you how to use your graphing calculator. Okay, so you're gonna learn multiple things today. You're gonna be awesome. So first things first, we have this data and it's in a chart, and this is a very special X. Okay, now it's not as special. So the table shows the braking distance for a particular car when traveling at a particular speed. So our speeds are our independent variables, our x's, because the speeds don't change. It is the y's that change based on the speed, okay? So that's our independent variable, our y's. So when the car is going 30 miles per hour, it's going to take 48 feet to stop, to come to a complete stop, okay? 40 and 80, 50 and 120, 60 and 180, 70 and 240, 80 and 320. Okay, so those are our points. So, step one, create a scatter plot. Now, remember, this is a video. At any point, you can pause it or rewatch it. So, I highly recommend that you do things before I do them, or try to do them on your own as much as possible, because the more you do on your own, the more you know, right? So, I labeled my x-axis, that's important. I labeled my y-axis, that's important. I labeled each one of my points. Now, in real life, you don't need to label those points. I just labeled them so you could see them very clearly, okay? I put my y-axis as going up by 50 because these are very big numbers. And if I go up by 25s or 5s, I wouldn't have enough room. And then I went up by 10s on my x-axis, because if I went up by 5s or 1s, I would not have enough room. So I got this. As you can see, and you're probably thinking in your brain, oh, Miss Thornton, that is a strongly positive, correlated looking points there. Those points look really like they're going to make a really nice positive line, and you're absolutely correct. But so now the thing is we have to use our calculators to figure out what that equation of the line is going to be. Now I'm going to teach you how to use your calculator to calculate your line of regression. So we have these data parts, right, or data table right here, okay? We're going to put that into our calculator. But first, before we do that, we have to press the second. So your calculator's going to have a little blinking arrow, and catalog. So we have to scroll all the way down to the D's. Takes a couple. Scroll. Okay. And you got to press enter. We need to turn the diagnostic on. You need to press enter again. Make sure it says done. Okay. Now we're ready. Stat. Okay. We're going to go edit. We're going to edit these lists just like we did with our standard deviation. So list 1 is going to be our x values. We're going to put our x values in here. 30. Oops, that's not 30. Gosh, because maybe I should look at what I'm doing here. 30, okay, down. 40, down. 50, down. 60, boop. 70, 80. That's it, right? It should be the same as on my chart. And then 48, 80, 120. I'm gonna square this guy up here. Burp. 120, 180. I guess I just press enter, didn't I? 240 and 320. I bet I did know that, but gotta make sure these are the same as those. Okay, now we're ready to do some real mathematics here. So we're going to press the stat button again. We're going to press calculate. we are going to go down to number 4, the linear regression, because we're trying to make a regression line, right? And we're going to press enter. And our list is going to be, or for X is going to be L1, and our list for Y is going to be L2. And now we're ready to calculate. Boom. It gave us our A, which is going to be our multiplier by our X, 5.42. So we see this guy right here. Okay. And then our B is negative 133.9, which I rounded both those. This is the one that we're going to use right here. 5.4x minus 134. And our R value is 0.99. See right here, it says 0.988, but we're going to round that to 0.99. Okay. So now we need to be able to interpret. My finger cut me off. I also forgot before we were going to the calculator about whether we were going to decide if, based on our scatter plot, a line of best fit would be a good idea. Now, you can say yes or no. I mean, you can make a decision on that, but these data points look pretty in a nice line. So you're probably going to be leaning towards yes and explaining why you think yes in your own words. And we kind of went over that yesterday or Wednesday, so why that might be a yes. So we have our line here. And for every increase in 1 mile per hour, the braking distance increases. And we have our multiplier 5.43, right? Or sorry, we're going to use 5.4. So that means every 5.4 feet, every 1 mile per hour. So every increase in 1 mile per hour on your car, you are, or especially, well, this specific car, you are increasing the braking distance by 5.4 feet. Okay. Now, when the speed of the car is 0 miles per hour, the stopping distance is, that's what the calculator said, but this is negative 134 is what we're going to use. That is the stopping distance. Now, can you have a negative stopping distance, or sorry, braking distance? Think about that one for a quick second. So go ahead and give yourself a minute to think about that and then circle yes or no. But I'm just letting you know, negative things in this case are probably not a thing. So think about that. All right, now we are ready to do the part of our lesson that is new to us today. So we are going to be looking at residuals and residual plots. A residual is the distance between the observed data value and its predicted value. Okay, we keep talking about predictions because our line of best fit is helping us predict, but we also know that we have the actual data. Okay, so as you can see here, we have our line now, and instead of just the x, I put that 30 in to I plugged it into our equation. So I did 5.4 times 30 minus 134, and that equals 28. Okay, so this is my prediction. Okay, now to find the residual value, you take the observed value, which is the one in our table, and you subtract the predicted value, the one we just found, and we got 20. Okay, so now I'm going to show you again how to do the second one. So y equals 5.4 stays the same. It is our constant increasing. Okay, we're multiplying that times 40 because our x is 40, and we're still going to subtract 134 from that. Okay, so I need to get back at my calculator, and I need to figure out how to get out of here. Okay, so we have 5.4 times 40 minus 134, 82. Okay, so our 82 guy goes right there. Now we look, our observed value is 80. Okay, but our predicted value is 82. So we go 80 minus 82. We go in our calculator. 80 minus 82. What do we get? -2. All right. So you're doing what I just did right here to find your residual values for the rest of these 4. You plug in the x, you get out the y. This is our predicted y. And then you do the actual or the observed minus the predicted to get this. These are your residuals. That's really bad, but you know what I'm talking about. So when you're finished, how many residuals are positive? Count up all the positive ones. How many residuals are negative? Count up all the negative ones. Okay? Then we get to our residual plot. Okay? You plot the residual points on the residual plot. Okay? First things first, I have to number my number line. It's going to be exactly the same as the first one I did for the x because the x's don't change. The x's stay the same. It is the y value or the residual value that now is what we're graphing. Okay? So when x equals 30, okay, oh, there we go. When x equals 30, y equals 20. So that's our residual plot, our first one. When x equals 40, y equals -2. So that's our second dot. And I did a little bit of extra for you, and I found out that this residual value is going to be -16. So when x equals 50, your residual is -16. So you need 3 more dots on your residual plot for the 60, 70, and 80 value. And you guys need to do those on your own because you definitely need to practice how to do them. Okay? Last but not least, interpreting each residual in the context of the problem, because you need to be able to understand the real-world applications of these problems. So at 30 miles per hour, the braking distance is 20 feet greater than predicted. And we can say it's 20 feet greater because this residual value is 20, positive 20. So positive meaning greater, okay, than predicted. We said 48, okay? Right, okay. At 40 miles per hour, the braking distance is 2 feet. Is it going to be greater than or less than? It's going to be less than because it's negative. Okay. So at 40 miles per hour, the braking distance is 2 feet less than predicted. So you take what these are and you're talking about what the prediction is, all right, based on the residual. Now, when you have all of your data points graphed, and this one starts up really high at 20 and it comes down, it's pretty close to 0, and then really high at -16, what are your other points? Is there going to be something that changes? So this is for you to do on your own, okay? So this is the first attempt at doing residual plot, and you took what you knew about doing the regression line and you added more knowledge, and you guys are going to be really close to being ready for our final project. I'm proud of you guys. Keep up the hard work, and I'll see you on Monday.